Tonight, we're drifting through the cosmic nursery, exploring one of the universe's most beautiful mysteries, where stars are born. I'm so glad you found your way here. Whether you're settling into bed, curling up on the couch, or simply trying to unwind after a long day of being wonderfully human. This is your quiet corner of the cosmos, where science puts on its softest voice and the universe shares its gentlest secrets. Before we begin our celestial journey, I'd love to know, where in the world are you watching from tonight? And what time is it in your corner of the sky? There's something magical about knowing we're all drifting together under the same stars, scattered across time zones but united by wonder. If you find this voyage soothing, intriguing, or just a lovely way to let your mind wander among the stars, I'd be ever so grateful if you gave the video a gentle like and perhaps subscribed. It helps this little haven of calm reach other stargazers who might need a peaceful pause in their evening too. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll drift off knowing a bit more about the cosmic cradles that birthed every atom in your body. Because that's what we're exploring tonight. Stellar nurseries. Those vast, dark clouds where gravity whispers matter together until it ignites into light. So settle in. Let your shoulders drop. Breathe slowly. And prepare to float through regions of space so beautiful and mysterious they seem almost too delicate to exist. We're going to visit the birthplaces of suns, the quiet corners of the galaxy where darkness gives way to brilliance, where simple hydrogen and dust transform into the very stars that light our nights. The story begins not with fire, but with cold, not with light, but with shadow. In the deepest, darkest regions of space, where temperatures hover just a few degrees above absolute zero, something extraordinary is quietly unfolding. These are the molecular clouds, vast stellar nurseries that stretch across hundreds of light years, containing enough material to birth thousands of suns. Picture, if you will, drifting through one of these cosmic gardens. At first glance, they appear empty, dark voids between the stars. But look closer, with instruments that can peer through the darkness, and you'll discover they're anything but empty. These clouds are filled with the raw ingredients of creation, mostly hydrogen, the universe's most abundant element, mixed with traces of heavier elements forged in the hearts of ancient stars that lived and died long before our sun was even a whisper of possibility. The density here is extraordinary in its subtlety. If you could gather all the material in a volume the size of Earth, you'd have less mass than a small pebble. And yet, across these immense distances, that tenuous matter adds up to something magnificent. Some molecular clouds contain hundreds of thousands of times the mass of our sun, all of it floating in the cosmic dark, patient and waiting. But waiting for what? For gravity to work its slow, inexorable magic. You see, even in these wispy, ethereal clouds, gravity is at work. It's incredibly gentle at first, barely perceptible, but it never stops. Wherever matter exists, even in the thinnest whisper of cosmic gas, gravity tugs. And given enough time, those gentle tugs begin to matter. The process starts almost imperceptibly. Perhaps a distant star explodes in a supernova, sending shock waves rippling through the cloud. Or maybe two clouds collide in a cosmic embrace that unfolds over millions of years. These disturbances create tiny variations in density, regions where the gas is just slightly thicker than its surroundings. And that's all gravity needs, the smallest of advantages, the faintest concentration of matter to begin its patient work. As gravity pulls more material into these denser regions, something beautiful begins to happen. The cloud starts to fragment, breaking up into smaller, more concentrated pockets. Each of these pockets becomes a potential birthplace for a star, a cosmic womb where matter will slowly compress and heat until it reaches the critical moment of nuclear ignition. But this is no rushed process. The collapse of a molecular cloud happens on timescales that dwarf human experience. What we're witnessing unfolds over millions of years, a slow-motion dance of matter and gravity that proceeds with the patience of geological ages. If you could watch one of these stellar nurseries over the course of a human lifetime, you'd see virtually no change at all. The drama is vast and slow, unfolding on cosmic time. As these pockets of gas continue to collapse under their own gravity, they begin to spin. This rotation is a consequence of conservation of angular momentum, the same principle that causes a figure skater to spin faster when they pull their arms close to their body. As the gas cloud contracts, it spins faster and faster, flattening into a disc shape with a dense central core. This is where things become truly fascinating. The center of the collapsing cloud, now spinning and heating from the compression, begins to glow with infrared light. It's not yet a star, not quite, but it's no longer just a cold cloud either. Astronomers call this stage a protostar, a stellar embryo that's still gathering material from its surrounding disk, still growing, still preparing for the moment when it will truly ignite. The temperature at the core continues to rise as more and more material falls inward. 10,000 degrees, 100,000, 1,000,000 degrees. The pressure becomes immense, squeezing the hydrogen nuclei closer and closer together, until finally, miraculously, they overcome their natural repulsion and begin to fuse. Hydrogen transforms into helium, releasing tremendous amounts of energy in the process. Nuclear fusion has begun, and a star is born. But even this moment of stellar birth is gentler than you might imagine. There's no sudden explosion, no dramatic flash of light. Instead, the new star gradually begins to shine, its nuclear furnace settling into a steady rhythm that may continue for billions of years. The leftover material in the surrounding disk may go on to form planets, moons, and all the countless smaller bodies that populate a stellar system. And so, from the cold darkness of a molecular cloud, warmth and light emerge. From the simplest elements, complexity is born. The stellar nursery has fulfilled its purpose, transforming the raw materials of the universe into the very stars that make galaxies shine, and ultimately make life itself possible. This process is happening right now, all around us in the galaxy. Even as you listen to these words, new stars are igniting in distant nurseries, beginning their long journeys through the cosmos. Looking at the sprawling nurseries where stars are born, we find ourselves drawn deeper into these cosmic workshops. The molecular clouds we've explored, those vast, dark wombs of hydrogen and dust, are just the beginning of an extraordinary process that transforms the emptiest reaches of space into bustling stellar neighborhoods. Within these clouds, gravity continues its patient work, but it doesn't operate alone. The newborn stars themselves become active participants in their own cosmic story, reshaping their birthplaces in ways both beautiful and violent. As protostars ignite and begin their nuclear dance, they unleash powerful stellar winds, streams of charged particles racing outward at hundreds of kilometers per second. These winds carve bubbles and cavities in the surrounding gas, like cosmic sculptors hollowing out cathedrals from the darkness. The most massive stars, burning bright and fast, live spectacular but brief lives. When they exhaust their nuclear fuel after just a few million years, a cosmic blink, They don't fade quietly into the night. Instead, they explode as supernovae, releasing more energy in seconds than our sun will produce in its entire 10 billion year lifetime. These stellar death throes send shockwaves rippling through space at thousands of kilometers per second, compressing nearby gas clouds and triggering new waves of star formation. It's a beautiful cycle. Stars are born, live, die, and in their death, give birth to the next generation. But stellar winds and supernova explosions do more than just trigger star formation. They also regulate it. Too much star formation too quickly would consume all available gas, leaving nothing for future generations. The energetic feedback from young, hot stars acts like a cosmic thermostat, heating and dispersing gas clouds when star formation becomes too vigorous. This creates a delicate balance, ensuring that star formation proceeds at a sustainable pace across billions of years. The heavy elements forged in stellar cores, carbon, oxygen, silicon, iron, and dozens of others, are scattered into space by these stellar winds and explosions. This cosmic recycling program gradually enriches the interstellar medium, transforming the pristine hydrogen and helium left over from the Big Bang into a more complex chemical soup. Each successive generation of stars is born from gas that's slightly richer in heavy elements than the last, enabling the formation of rocky planets, complex molecules, and eventually, life itself. Some star-forming regions become so active that they earn the title starburst regions, cosmic maternity wards, where hundreds or thousands of stars are born in relatively short periods. The Orion Nebula, visible to the naked eye as a fuzzy patch in the constellation Orion, is one such stellar nursery. Within its glowing gas clouds, young stars illuminate their surroundings with ultraviolet light, creating the beautiful pink and red hues we see in astronomical photographs. These are hydrogen atoms, stripped of their electrons by stellar radiation and glowing as they recombine. The same process that creates the aurora in Earth's atmosphere, but on an incomparably grander scale. The architecture of star formation extends far beyond individual clouds. Across entire galaxies, spiral arms act as cosmic assembly lines for star birth. As gas clouds orbit the galactic center, they encounter these spiral density waves, regions where matter becomes compressed, much like cars bunching up in traffic. This compression triggers star formation along the spiral arms, which is why galaxies like our own Milky Way appear to have strings of bright, young stars tracing their elegant curves. Not all stars are born equal. The mass of a forming star determines its entire life story, how bright it will shine, how long it will live, and how it will die. The smallest stars, red dwarfs with less than half the mass of our sun, burn their fuel so slowly that they can shine for trillions of years. In contrast, the most massive stars, blue giants dozens of times heavier than the sun, burn through their nuclear fuel in just a few million years before exploding as supernova. The universe has been around for less than 14 billion years, so every blue giant we see in the night sky is necessarily young, a cosmic teenager in stellar terms. Perhaps most remarkably, we now know that many stars are born not in isolation, but as part of multiple star systems. Binary and triple star systems are actually more common than single stars like our sun. In these cosmic partnerships, stars can exchange material, alter each other's evolution, and sometimes engage in spectacular stellar cannibalism, with one star gradually devouring its companion. These interactions add layers of complexity to stellar evolution, creating exotic objects like white dwarf stars, neutron stars, and black holes. The process of star formation also gives birth to planetary systems. The same rotating disk of gas and dust that feeds a growing protostar also provides the raw material for planets. Tiny dust grains stick together to form pebbles. Pebbles aggregate into boulders, and boulders eventually grow into planets. This process of planetary formation appears to be a natural consequence of star birth, suggesting that planetary systems may be common throughout the universe. Modern telescopes have revolutionized our understanding of stellar nurseries. Infrared observations can peer through dust clouds that block visible light, revealing the hidden stellar nurseries within. Radio telescopes detect the faint emissions from cold molecular gas, mapping the raw materials from which stars form. Space-based observatories, free from the blurring effects of Earth's atmosphere, capture images of star formation with breathtaking clarity and detail. As we continue to study these cosmic cradles, we're learning that star formation is not just a local phenomenon, but a process that shapes the evolution of entire galaxies. The rate at which a galaxy forms stars influences its color, structure, and ultimate fate. Galaxies that have exhausted their star-forming gas appear red and quiet, dominated by aging stars. Those still actively forming stars blaze with the blue light of hot, young stellar populations. The story of star formation is ultimately our story too. Every atom in your body, except for hydrogen, was forged in the nuclear furnace of a star and scattered into space when that star died. We are, quite literally, made of star stuff, the product of countless cycles of stellar birth, life, and death stretching back billions of years. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were created in stellar cores and distributed through space by the very processes we've been exploring. And so the cosmic cycle continues. Even now, in molecular clouds scattered throughout our galaxy and beyond, gravity is gathering gas and dust into new protostars. Some will become stars like our sun, burning steadily for billions of years. Others will live fast and die young, exploding as supernovae and seeding space with the heavy elements needed for the next generation. Now, as cosmic architects begin their work, we witness one of the universe's most profound transformations. Those first scattered stars, brilliant and brief, had done more than simply light the darkness. In their violent deaths, they scattered the seeds of complexity across the cosmos, enriching the primordial hydrogen and helium with heavier elements. Carbon, oxygen, silicon, iron, the building blocks of worlds, of life, of stories yet to be told. These stellar ashes didn't drift aimlessly through space. Gravity, ever patient, ever persistent, began gathering them into vast rotating disks around newborn stars. Within these swirling nurseries of dust and gas, something extraordinary was about to unfold. The birth of planetary systems. Our own solar system, formed some 4.5 billion years ago, is but one example of this cosmic choreography, a dance between matter and motion that plays out around countless stars throughout the galaxy. But planets are just the beginning. As these worlds settled into their orbits, some found themselves in that precious zone astronomers call the habitable region. Not too hot, not too cold, but just right for liquid water to exist on their surfaces. And water, as we've come to understand, is the solvent of life, the medium in which the chemistry of existence can flourish. On at least one of these worlds, perhaps many more than we yet know, the stellar recycling process achieved something truly miraculous. The carbon forged in ancient stellar cores began forming complex molecules. Amino acids assembled into proteins. RNA learned to replicate itself. And somewhere in the warm pools or deep ocean vents of a young Earth, life took its first tentative steps. This is the profound connection that binds us to the stars. Every atom in your body, save for the hydrogen, was forged in the nuclear furnaces of dying stars. The calcium in your bones, the iron in your blood, the oxygen you breathe. All of it was once part of a star that lived and died long before our sun was even a glimmer in a cosmic cloud. We are, quite literally, made of star stuff. But more than that, we are the universe becoming aware of itself. Through our eyes, the cosmos looks back upon its own history. Through our minds, it contemplates its own existence. We are not separate from the cosmic story we've been exploring. We are its most recent chapter, conscious beings capable of wonder, of curiosity, of the very questions that drive us to build telescopes and peer into the depths of space and time. The stellar nurseries continue their work even now. In the Eagle Nebula, the Orion Nebula, and countless other star-forming regions throughout our galaxy, gravity sculpts pillars of creation where new stars are being born. Some of these stars will host planets. Some of those planets may harbor life, and perhaps, billions of years from now, other conscious beings will look up at their night sky and wonder, as we do, about their place in the grand cosmic tapestry. This is the legacy of stellar birth and death. Not just the creation of heavy elements, but the possibility of complexity, of beauty, of consciousness itself. Every sunset you've ever watched, every flower that's bloomed, every thought you've ever had exists because stars lived, died, and scattered their enriched contents into the cosmos. The iron that colors autumn leaves red was forged in a supernova. The gold in your jewelry was likely created in the collision of neutron stars, those incredibly dense remnants of stellar death. And so we come full circle in our cosmic journey, from the first stirrings of matter in primordial molecular clouds, to the ignition of nuclear fusion in stellar cores, to the explosive deaths that seed space with the elements of planets and life. Stars are not just distant lights in the night sky. They are our ancestors, our creators, the cosmic forges that made our existence possible. Tonight, as you drift towards sleep, perhaps you'll step outside for just a moment and look up at the stars. Each pinprick of light represents a nuclear furnace, burning bright across the darkness, continuing the ancient cycle of stellar birth, life, and death that has been shaping the universe for over 13 billion years. Some of those stars are young, hot, and blue, racing through their lives in mere millions of years. Others are old, cool, and red, burning steadily for tens of billions of years. And somewhere among them, perhaps around stars we cannot even see from Earth, other worlds orbit in their own habitable zones. Other stories may be unfolding. Other forms of consciousness may be emerging, all thanks to the stellar alchemy that transforms simple hydrogen into the rich complexity we see around us. This is the profound beauty of our cosmic origins. We are not accidental visitors to the universe. We are its children, born from stellar death and nurtured by stellar light. Every breath you take connects you to the cosmic cycles that have been operating since the first stars began to shine. You are part of an unbroken chain of stellar generations, each one building upon the last, creating ever greater complexity and beauty. Sleep well, knowing that you carry within you the legacy of countless stars. Their light flows through your veins, their elements form your thoughts, and their story continues in every moment of your existence. We've journeyed through the birth of matter itself, watched the first stars ignite in primordial darkness, and witnessed galaxies slowly gathering into their majestic forms. Now, As we drift deeper into our cosmic story, it's time to explore one of the most profound questions in all of astronomy. Are we alone? The universe we've been exploring together, this vast tapestry of billions of galaxies, each containing billions of stars, raises an almost inevitable possibility. With so many worlds scattered across the cosmos, surely some of them must harbor life, perhaps even intelligent life, civilizations that have gazed up at their own night skies and wondered the very same thing we're wondering right now. But here's where our story takes a curious turn. Despite the overwhelming mathematical likelihood that life should exist elsewhere, despite decades of searching and listening, we find ourselves in what scientists call the Great Silence. The universe, for all its grandeur and complexity, seems remarkably quiet when it comes to the voices of other civilizations. This isn't just a modern mystery. As soon as humans began to grasp the true scale of the cosmos, we started asking why the heavens seemed so empty of company. In 1950, the physicist Enrico Fermi posed the question that would become famous as the Fermi paradox. If the universe should be teeming with life, where is everybody? The numbers are staggering when you really consider them. Our galaxy alone contains somewhere between 100 and 400 billion stars. Many of these stars have planets orbiting them, and a significant fraction of those planets exist in what we call the habitable zone, that Goldilocks region where liquid water can exist on a planet's surface. Not too hot, not too cold, but just right for the chemistry of life as we know it. Even if we're extraordinarily conservative in our estimates, even if only 1 in a million stars hosts a planet with life, even if only 1 in a million of those develops intelligence, we should still expect thousands, perhaps millions of civilizations in our galaxy alone. And yet, when we turn our radio telescopes to the sky, when we scan for artificial signals or signs of vast engineering projects, we hear nothing but the gentle hum of cosmic background radiation. This silence is particularly puzzling when we consider the age of the universe. 8 billion years old, the cosmos has had plenty of time for life to emerge, evolve, and spread. 6 billion years ago. There were billions of years before us during which other civilizations could have arisen, developed technology, and begun exploring the galaxy. Some of these civilizations might have had a head start of hundreds of millions, even billions of years. Given how rapidly our own technology has advanced in just the past century, imagine what a civilization with a million-year head start might be capable of. They could have colonized their entire galaxy, built structures visible across interstellar distances, or developed forms of communication we haven't even dreamed of yet. And yet, the silence persists. This puzzle has spawned countless theories, each attempting to explain why the universe appears so devoid of the chatter and activity we might expect from a cosmos rich with life. Some of these explanations are hopeful, suggesting that civilizations are out there but we simply haven't found the right way to detect them yet. Others are more sobering, proposing that something prevents most life from reaching the level of complexity and longevity required for interstellar communication. There's the possibility that we're looking in the wrong places or listening for the wrong signals. Perhaps advanced civilizations have moved beyond radio waves and electromagnetic radiation, communicating through methods we haven't discovered or can't yet comprehend. Maybe they've learned to harness quantum entanglement for instantaneous communication, or perhaps they encode their messages in gravitational waves or dark matter fluctuations. Or consider this. What if civilizations naturally tend toward subtlety rather than broadcasting their presence? On Earth, our own technology is becoming more efficient and less detectable from the outside. Our communications are increasingly digital, compressed, and encrypted. Instead of powerful radio broadcasts that leak into space, we're moving toward fiber optic cables, satellite networks, and targeted transmissions that would be nearly impossible for distant observers to detect. Then there are the more troubling possibilities. Perhaps there's something inherent in the development of intelligence that makes long-term survival difficult. Civilizations might consistently destroy themselves through warfare, environmental destruction, or technological catastrophe before they become capable of interstellar communication. The same intelligence that allows a species to develop powerful technology might also make them prone to using that technology in destructive ways. This is sometimes called the Great Filter Hypothesis. The idea is that there's some evolutionary or technological hurdle that's extremely difficult to overcome. It might be the development of life itself, the transition from simple to complex cells, the evolution of intelligence, or the challenge of creating a stable technological civilization. If this filter lies behind us, then we're among the lucky few who made it through. If it lies ahead of us, well, that's a more uncomfortable thought. Some scientists have proposed that advanced civilizations might deliberately keep themselves hidden, following something like a cosmic version of the Prime Directive from Star Trek. Perhaps there's a galactic ethical code that prevents mature civilizations from interfering with younger ones. They might be out there, watching us with benevolent interest, but waiting for us to reach some threshold of wisdom or technological capability before making contact. Or maybe the universe is structured in a way that makes contact between civilizations extremely rare, even if those civilizations are relatively common. Space is vast beyond human comprehension. Even if there are thousands of active civilizations in our galaxy, they might be separated by such enormous distances and time scales that meaningful communication is effectively impossible. Two civilizations might rise and fall without ever knowing of each other's existence, like ships passing in the cosmic night. There's also the intriguing possibility that we're asking the wrong question entirely. We assume that other civilizations would want to communicate across interstellar distances, that they would build large, detectable structures, or that they would even remain on planets at all. But perhaps truly advanced civilizations turn inward rather than outward. Maybe they discover that the most interesting and rewarding explorations are not of outer space, but of inner space, consciousness, virtual realities, or dimensions of existence we can't yet imagine. Some researchers have suggested that sufficiently advanced beings might prefer to build compact, efficient computational systems rather than sprawling galactic empires. Why spread across the galaxy when you can create entire universes of experience within a space the size of a computer? This could explain why we don't see evidence of vast stellar engineering projects, the kind of megastructures that should be visible from great distances if civilizations were expanding across the cosmos. And then there's the possibility that life itself is far rarer than we assume. Perhaps the conditions that led to life on Earth were so specific, so unlikely, that we might be genuinely alone in our galaxy, possibly even in the observable universe. The more we learn about the requirements for life, the more complex and interconnected they appear. Earth needed not just liquid water and a suitable temperature, but also a large moon to stabilize its rotation, a magnetic field to protect from radiation, the right kind of star, a position in the galaxy that avoided too much cosmic violence, and countless other factors. Carl Sagan once said that extraordinary claims require extraordinary evidence, and perhaps the claim that we're alone in the universe is extraordinary enough to require careful consideration. It would make us not just rare, but precious beyond measure, the universe's way of coming to know itself through conscious observation. Yet even as we ponder these sobering possibilities, the search continues. Projects like SETI, the search for extraterrestrial intelligence, maintain their patient vigil, scanning the skies for any hint of artificial signals. New telescopes and detection methods are constantly being developed, each offering fresh hope that we might finally hear that first whisper from the cosmic dark. We're also learning to look for more subtle signs of life. Instead of just listening for deliberate communications, astronomers are beginning to search for the atmospheric signatures of living worlds. When starlight passes through a planet's atmosphere, it carries with it the chemical fingerprints of whatever gases are present. Oxygen, methane, water vapor, and other compounds associated with life might betray the presence of biology, even if that life has never developed technology. The James Webb Space Telescope and other next-generation instruments are opening new windows into the cosmos, capable of detecting these biosignatures around nearby stars. Within the next few decades, we may have surveyed hundreds or thousands of potentially habitable worlds, building a comprehensive catalog of which ones show signs of life. And perhaps most excitingly, we're beginning to understand that life might be possible in places we never expected. The moons of Jupiter and Saturn, worlds like Europa and Enceladus, harbor vast oceans beneath their icy surfaces. These alien seas might be home to ecosystems completely independent of sunlight, powered instead by the tidal heating from their giant parent planets. If life can thrive in such environments, then the number of potentially habitable worlds in our solar system alone jumps from 1 to half a dozen or more. So as we drift through this cosmic mystery, suspended between hope and uncertainty, we find ourselves in a curious position. We live in a universe that seems perfectly designed to produce life, filled with the raw materials and energy sources necessary for biology, yet we remain apparently alone in our little corner of it. But perhaps that's exactly as it should be. Perhaps the silence isn't empty but pregnant with possibility. Perhaps we're not alone but simply early, the first to develop the ability to ask these questions and search for answers. Perhaps we're destined to be the ones who break the great silence, to become the civilization that others will someday detect and wonder about. Or perhaps the universe is trying to teach us something about patience, about the value of mystery, about the importance of continuing to search even when the answers seem impossibly distant. Every night, radio telescopes around the world continue their quiet listening, and every day, new worlds are discovered orbiting distant stars. The great silence may not last forever, and when it finally breaks, when we detect that first confirmed signal from another civilization or discover unmistakable signs of life on a distant world, it will mark one of the most profound moments in human history. We will no longer be alone with our questions about existence, consciousness, and our place in the cosmic story. Until then, we wait, we search, and we wonder. And in our wondering, we keep alive one of the most beautiful aspects of human nature, our refusal to accept that we might be the only voices singing in the cosmic choir. Somewhere out there, perhaps another civilization is doing exactly what we're doing, gazing up at their night sky and asking the very same questions that have captivated us tonight. The universe may be silent for now, but it's a silence full of potential, pregnant with possibilities we've yet to discover. In the vast cosmic ocean surrounding us, countless stellar nurseries continue their ancient work, quietly weaving the next chapters of our universe's story. We've journeyed together through the birth pangs of stars, witnessed the delicate dance of gravity and gas, and marveled at how these cosmic cradles scatter the very elements that make planets, moons, and eventually life itself possible. But perhaps the most profound revelation isn't just how stars are born, but what their births mean for the grand tapestry of existence. Every stellar nursery we've explored represents not an ending, but a beginning. When massive stars collapse and explode as supernovae, they don't simply die. They give the ultimate gift, seeding space with heavy elements like carbon, oxygen, and iron. These stellar ashes drift through the cosmos, eventually finding their way into new molecular clouds, enriching them and making the next generation of stars even more capable of fostering complex chemistry. This cosmic recycling program has been running for over 13 billion years, each generation of stars building upon the legacy of those that came before. The calcium in our bones, the iron in our blood, the oxygen we breathe. All of it was forged in the nuclear furnaces of ancient stars and scattered across space in their final moments. We are, quite literally, made of star stuff, connected to every stellar nursery that has ever existed through an unbroken chain of cosmic inheritance. The molecular clouds we visited tonight, those dark, cold regions where stars slowly gather themselves from wisps of hydrogen and dust, represent hope on the grandest scale imaginable. They remind us that even in the apparent emptiness of space, creativity persists. Even in the coldest, darkest corners of the galaxy, gravity works patiently to kindle new lights. The universe, far from winding down, continues to reinvent itself, star by star, nursery by nursery. And what of the planets that form alongside these newborn stars? Each planetary system is a unique experiment in cosmic chemistry, a laboratory where the elements scattered by long-dead stars can combine in ways we're only beginning to understand. Some worlds become frozen ice balls, others molten hellscapes, but a precious few find themselves in that narrow zone where liquid water can exist, where complex molecules can dance together, where life might take its first tentative steps. Recent discoveries have shown us that planets are not rare cosmic accidents, but common companions to stars. Nearly every stellar nursery we study reveals planetary systems in various stages of formation, disk upon disk of dust and gas slowly coalescing into worlds. Some of these planets orbit in the habitable zones of their stars, that Goldilocks region where temperatures are just right for liquid water and perhaps, just perhaps, for biology to emerge. This brings us to one of the most tantalizing questions raised by our exploration of stellar nurseries. Are we alone? If stars are constantly being born, if planets form routinely around them, if the elements of life are scattered throughout the cosmos, then surely life itself must be equally common. Yet when we scan the sky with our most sensitive instruments, when we listen for signals from distant civilizations, we hear only silence. This cosmic quiet, known as the Fermi paradox, presents us with a puzzle. Where is everybody? Perhaps life is far rarer than we imagine, requiring not just the right chemical ingredients, but an incredibly specific sequence of unlikely events. Perhaps intelligence is even rarer still, or perhaps civilizations inevitably destroy themselves before they can reach out to the stars. Or maybe they're out there, but using forms of communication we haven't yet discovered, or choosing to remain hidden for reasons we can't fathom. But there's another possibility, one that fills me with quiet optimism as we drift toward the end of our journey tonight. Perhaps we're simply early to the party. The universe is still young by cosmic standards, still actively forming new stars and planets. The stellar nurseries we've explored tonight are not ancient history, but ongoing processes, cosmic maternity wards that will continue operating for billions of years to come. Maybe we're among the first to develop technology, to ask questions about our place in the cosmos, to wonder about our neighbors among the stars. If that's true, then our responsibility becomes even more profound. We may be the universe's first conscious witnesses to its own beauty, the first creatures capable of understanding stellar nurseries and appreciating their role in the cosmic story. We may be the first to realize that we are not separate from the cosmos, but intimately woven into its fabric, children of ancient starlight contemplating our stellar heritage. The search for life beyond Earth continues, of course. Our telescopes grow more powerful, our detection methods more sophisticated. The James Webb Space Telescope peers into the atmospheres of distant worlds, looking for the chemical signatures of life. Radio telescopes scan the heavens for artificial signals. Robotic explorers investigate the potentially habitable moons of Jupiter and Saturn. Each new mission brings us closer to answering that fundamental question: are we alone? But even if we remain the only known life in the universe, even if our searches continue to yield silence, we should not despair. The stellar nurseries remind us that the cosmos is still creating, still experimenting, still bringing forth new possibilities. Every star born today increases the chances that somewhere, somewhen, other forms of consciousness will emerge to witness the universe's splendor, and perhaps to join us in contemplating the magnificent stellar cradles where it all begins. The silence we currently observe may not be permanent. It may simply be the quiet before a cosmic conversation that spans millennia. Future generations may look back on our era as the moment when Earth's children first began reaching out to touch other worlds, to search other skies, to listen for other voices in the vast cathedral of space. Tonight, as you rest beneath the same stars that have watched over countless generations of stellar birth and death, remember that you are part of this continuing story. The stellar nurseries are still at work, still weaving new chapters in the universe's biography. And you, made of elements forged in ancient stellar hearts, carry within yourself the accumulated wisdom of billions of years of cosmic evolution. We arrive now at a quieter moment in our cosmic journey, though no less wondrous than what has come before. Having witnessed the birth of stars and the formation of stellar nurseries, we find ourselves contemplating one of the most profound questions that arises from all this celestial abundance. Are we alone? It's a question that whispers through the corridors of every observatory, drifts through the calculations of every astronomer, and settles gently into the thoughts of anyone who has ever gazed up at a star-filled sky. With billions upon billions of stars scattered across the observable universe, each potentially hosting planets, and with the knowledge that the very elements of life, carbon, oxygen, nitrogen, were forged in stellar cores and scattered by ancient supernovae, it seems almost impossible that Earth would be the only world to harbor life. And yet, here we sit in what appears to be a vast, silent cosmos, listening for signals that never come, searching for signs that remain hidden. This paradox, this gentle contradiction between expectation and observation, has a name. The mathematics of the situation seem to suggest we should be drowning in cosmic company. Our galaxy alone contains hundreds of billions of stars, many of them similar to our Sun, many of them hosting planets in what we call the habitable zone, that sweet spot where liquid water can exist on a planet's surface. Even if life is extraordinarily rare, emerging on only one planet in a million, our galaxy should still teem with thousands of living worlds. And if even a tiny fraction of those worlds developed intelligent, technologically capable civilizations. We should see evidence of them everywhere: radio signals, megastructures, signs of engineering on astronomical scales. Some of those civilizations would be millions, even billions of years older than ours. They would have had eons to spread across the galaxy, to build, to communicate, to make their presence known. The universe is old enough that intelligence could have arisen countless times, in countless places, with countless opportunities to reach out across the cosmic dark and say hello. But the radio telescopes remain largely quiet. The searches for artificial signals turn up natural phenomena, pulsars, quasars, the background hum of cosmic radiation. The skies show us planets and moons and asteroid belts, but no cities of light, no impossible constructions, no beacons calling across the void. It's as if we're living in a universe that should be bustling with conversation, but instead we hear only our own voices echoing back. This silence has spawned dozens of potential explanations, each more intriguing than the last. Perhaps life itself is far rarer than we imagine. Perhaps the jump from simple chemicals to self-replicating organisms requires such an unlikely sequence of events that it happens only once in a trillion worlds. Or perhaps life is common, but intelligence is not. After all, life existed on Earth for billions of years before anything resembling human intelligence emerged. Maybe most living worlds are content with their microbial gardens, their bacterial seas, never developing the curious, tool-making minds that build radio telescopes and wonder about distant stars. Another possibility is that intelligent civilizations tend to destroy themselves before they can spread beyond their home worlds. Nuclear weapons, climate change, artificial intelligence, biotechnology, all of these present existential risks that a developing civilization must navigate. Perhaps the universe is littered with the remains of species that reached our level of technology but couldn't find wisdom to match their power. It's a sobering thought, and one that gives weight to every choice we make as a species about our own future. But there are gentler explanations too. Perhaps advanced civilizations simply have no interest in communication with younger species like ourselves. They may have transcended the need for crude radio signals, communicating instead through technologies we can't even imagine. Or they may have turned inward, creating virtual realities so rich and satisfying that the physical universe holds little appeal. Why explore the galaxy when you can create infinitely detailed worlds within the confines of your own planet? Some scientists suggest that we're looking in the wrong places or at the wrong times. Maybe alien civilizations communicate using neutrinos or gravitational waves, or some other phenomenon we've barely begun to understand. Maybe they visited our solar system millions of years ago, long before humans existed, and found nothing interesting enough to warrant a return trip. Maybe they're here now, but so different from us that we don't recognize them as life at all. There's also the possibility that we are, in fact, among the first. The universe is 13.8 billion years old, but for most of that time, it was not particularly hospitable to life as we know it. Heavy elements had to be forged in stellar cores and scattered by supernovae. Planets had to form and cool. Atmospheres had to stabilize. Perhaps we're living in the first era when complex life is truly possible, and we're simply among the early arrivals to the cosmic party. Or perhaps the answer is distance and time. Space is unimaginably vast, and civilizations rise and fall on timescales that may rarely overlap. Two intelligent species might exist in the same galaxy, might even be relatively close to each other as galactic distances go. But if one flourishes while the other is still evolving in primordial seas, they'll never meet. The universe might be full of intelligence, but scattered across such enormous stretches of space and time that contact is virtually impossible. Then there are the more speculative ideas. Maybe advanced civilizations deliberately hide themselves, following some cosmic ethics that prevents them from interfering with younger species. Maybe there's a galactic club of civilizations that only admits members once they've proven they can survive their own technological adolescence. Maybe the universe is stranger than we imagine, with most intelligence existing in dimensions or states of being we haven't discovered yet. As we continue to search, the tools grow more sophisticated, the methods more refined. Projects like SETI, the search for extraterrestrial intelligence, scan the skies for artificial signals. Space telescopes analyze the atmospheres of distant planets, looking for chemical signatures that might indicate life. Scientists study extremophiles, organisms that thrive in conditions once thought impossible for life, expanding our understanding of where and how life might exist. Each new discovery raises the stakes of the Fermi paradox. Every Earth-like planet we find, every organic molecule detected in space, every sign that the universe is rich with the ingredients of life, makes the silence more profound and more puzzling. We're learning that the universe is not a sterile, empty place, but one where the building blocks of life are common, where potentially habitable worlds are numerous, where the stage seems set for a grand biological drama. And yet, for now, we appear to be alone on that stage, speaking our lines to an empty theater, wondering if anyone else is out there, perhaps wondering the same thing about us. The search continues, though, because the question matters too much to abandon. Whether we find evidence of other intelligence or remain alone in our cosmic contemplation, the very act of searching changes us, expands our perspective, reminds us that we are part of something vast and mysterious and wonderful. Perhaps the silence is temporary, and tomorrow we'll detect that first artificial signal from another world. Perhaps we are alone, and the responsibility for bringing consciousness and wonder to the universe rests entirely with us. Or perhaps the truth is stranger and more beautiful than any explanation we've yet imagined. For now, we continue to listen, to search, to wonder. Looking at the stellar nurseries where new worlds take shape, we find ourselves at the edge of possibility. The cosmic cradles that birth stars don't just create blazing spheres of nuclear fire. They craft entire planetary systems, some harboring conditions so remarkably similar to our own that they whisper tantalizing questions about life beyond Earth. Within those swirling disks of gas and dust surrounding newborn stars, gravity works with the patience of a master sculptor. Tiny grains of cosmic dust, no bigger than particles of smoke, begin their slow dance of accretion. They collide gently at first, sticking together through electrostatic forces and van der Waals attractions. Grain by grain, these microscopic building blocks grow into pebbles, then boulders, then planetesimals, the seeds of future worlds. The process is delicate, almost impossibly so. Too much turbulence in the disk, and the growing particles are torn apart before they can mature. Too little material, and planets never form at all. But when conditions align, when the temperature gradients are just right and the stellar winds aren't too fierce, something magical happens. Rocky planets form in the warm inner regions where metals and silicates can condense. Further out, beyond the frost line where water vapor freezes into ice, gas giants gather vast atmospheres around solid cores. And sometimes, just sometimes, a planet forms at precisely the right distance from its star. Not too hot, not too cold, but in that precious zone astronomers call the habitable zone. Here, liquid water can exist on a planetary surface. Here, the complex chemistry of life as we know it becomes possible. We've discovered thousands of these exoplanets now, orbiting distant stars throughout our galaxy. Some are scorching hot Jupiters, gas giants that spiral so close to their stars that their atmospheres boil away into space. Others are frozen super-Earths, rocky worlds larger than our own but locked in perpetual winter. But among them, we've found treasures. Planets that orbit their stars at just the right distance. Planets with atmospheres that might trap warmth. Planets where seasons change and weather systems churn. Consider Kepler 452b, sometimes called Earth's cousin, orbiting a star remarkably similar to our Sun. Or TRAPPIST-1, a small red dwarf star with 7 Earth-sized planets, 3 of which sit squarely in the habitable zone. These worlds represent more than just points of light in our telescopes. They represent the possibility that Earth's story of life might not be unique. The formation of these planetary systems follows patterns we're only beginning to understand. Some stars birth their planets quickly, in just a few million years, while others take their time, allowing the process to unfold over tens of millions of years. The chemistry varies too. Stars richer in heavy elements tend to form more diverse planetary systems, with rocky worlds and complex atmospheric compositions. But perhaps most remarkably, we've learned that planetary formation doesn't end when the disk of material is exhausted. Planets migrate, sometimes moving inward toward their stars, sometimes drifting outward. They can be ejected entirely from their systems, becoming lonely wanderers in the darkness between stars. Others collide and merge, creating hybrid worlds with compositions unlike anything in our solar system. The habitable zones themselves are dynamic, changing as stars age and evolve. A planet that begins its life too hot for liquid water might find itself in the perfect temperature range millions of years later as its star settles into a more stable phase. Conversely, worlds that start out warm and welcoming might freeze as their stars begin to fade. This cosmic choreography of planetary birth and evolution plays out across the galaxy in stellar nurseries both ancient and newly formed. Each system tells its own story, shaped by the unique conditions of its stellar cradle. Some stories end quickly, with planets spiraling into their stars or being blasted away by stellar winds. Others unfold over billions of years, allowing time for atmospheres to stabilize, for water cycles to develop, for the slow chemistry of prebiotic evolution to take hold. The diversity is staggering. We've found planets with atmospheres of pure hydrogen, worlds where it rains liquid methane, and rocky planets so close to their stars that their surfaces are molten lava. We've discovered planets orbiting binary star systems, where 2 suns rise and set in alien skies, and worlds that orbit their stars backwards, suggesting violent histories of collisions and gravitational disruption. Yet for all this cosmic variety, we keep returning to those special cases, the worlds that remind us of home. Planets with day-night cycles similar to Earth's, with seasonal variations driven by axial tilts, with moons that stabilize their rotation and create tides in their oceans. These Earth-like worlds represent our best hope for finding life beyond our solar system. Places where the familiar chemistry of carbon, hydrogen, oxygen, and nitrogen might weave together into the complex patterns we call biology. The search continues, driven by increasingly sophisticated telescopes and detection methods. We can now analyze the atmospheres of distant exoplanets, looking for the telltale signatures of oxygen, methane, and water vapor. We can detect the subtle gravitational influences of planets on their host stars, revealing systems of multiple worlds locked in orbital resonances. We can even begin to map the weather patterns on these distant worlds, watching storms larger than Jupiter rage across their surfaces. Each new discovery adds another piece to the grand puzzle of planetary formation and evolution. We're learning that our solar system, once thought to be typical, is actually quite unusual in its architecture and stability. Most planetary systems are far more chaotic, with hot Jupiters spiraling close to their stars and super-Earths, a class of planet that doesn't exist in our neighborhood, dominating the census of known worlds. But this cosmic diversity only makes the search for Earth-like planets more exciting. If nature can craft such a wide variety of worlds from the raw materials of stellar nurseries, then surely among the hundreds of billions of stars in our galaxy, there must be others that have followed a path similar to our own. Worlds where liquid water flows, where atmospheres protect and nurture rather than destroy, where the conditions are just right for the emergence of life. As we peer deeper into space and further back in time, we're beginning to see the very first generations of planetary systems forming around ancient stars. These primordial worlds, born from the ashes of the universe's earliest stellar generations, represent the first opportunities for life to take hold in cosmic history. They remind us that the process of planetary formation has been ongoing for most of the universe's existence, suggesting that Earth-like worlds might be far more common than we once dared to hope. The stellar nurseries continue their work, even now, crafting new worlds in distant corners of the galaxy. Each collapse of a molecular cloud, each ignition of a protostar, each swirling disk of cosmic material represents another chance for nature to experiment with planetary architecture. Another opportunity for the universe to create conditions suitable for life. As we've explored the cosmic cradles where stars are born, we now turn to one of the most profound mysteries in our universe, the apparent silence. Despite the vast number of potentially habitable worlds scattered across billions of galaxies, despite the countless opportunities for life to emerge and evolve, we find ourselves listening to what seems like an empty cosmos. The question seems almost childlike in its simplicity, yet it cuts to the heart of one of the most perplexing puzzles in all of science. 8 billion years, and if it contains as many stars and planets as our observations suggest, then surely intelligent civilizations should have arisen elsewhere. Some of these civilizations might be millions or even billions of years older than our own, giving them ample time to develop technologies we can barely imagine, to spread across their home galaxies, to leave unmistakable signatures of their presence. And yet, when we scan the skies with our most sensitive instruments, when we listen for deliberate signals or search for the telltale signs of advanced engineering projects, we find nothing. No radio transmissions carrying alien news broadcasts, no massive structures built around distant stars to harvest their energy, no fleets of spacecraft moving between worlds. The cosmos appears to be filled with planets and possibility, but devoid of the bustling activity we might expect from a universe teeming with intelligence. Consider the numbers for a moment. Our galaxy alone contains somewhere between 100 and 400 billion stars. Even if only a tiny fraction of those stars host planets in the habitable zone, that still leaves millions of potentially life-bearing worlds in the Milky Way alone. Scale that up to the observable universe, with its hundreds of billions of galaxies, and the numbers become almost incomprehensible. Surely, in all that vastness, life should have found a way not just to exist, but to thrive, to grow intelligent, to reach for the stars. This line of reasoning led astronomer Frank Drake to formulate what's now known as the Drake equation in 1961, an attempt to estimate the number of communicating civilizations in our galaxy. The equation breaks down the problem into factors: the rate of star formation, the fraction of stars with planets, the number of planets that could support life, the fraction where life actually develops, the fraction where intelligent life emerges, the fraction that develops detectable technology, and finally, how long such civilizations remain detectable. When Drake first plugged numbers into his equation, he estimated there might be anywhere from 1 to millions of communicating civilizations in our galaxy. But here's the unsettling part. Even if we use conservative estimates, even if we assume that intelligent life is extraordinarily rare, the sheer age and size of the universe suggests that someone, somewhere, should have beaten us to the punch. Some civilization should have arisen millions of years ago, developed interstellar travel, and begun the slow process of colonizing the galaxy. At modest speeds, well within the realm of known physics, a single civilization could spread across the entire Milky Way in just a few million years, a blink of an eye in cosmic terms. So where are they? This absence of evidence has spawned countless theories, each more intriguing than the last. Perhaps intelligent life is far rarer than we imagine. Maybe the jump from simple microbes to complex, tool-using beings requires such an unlikely sequence of events that Earth represents a cosmic lottery win of staggering proportions. This is sometimes called the rare Earth hypothesis, which suggests that while simple life might be common, the specific conditions needed for complex, intelligent life are so precise that we might be effectively alone. Or perhaps intelligence does arise frequently, but civilizations tend to destroy themselves shortly after developing powerful technologies. The gap between discovering fire and splitting the atom took humans hundreds of thousands of years, but the gap between splitting the atom and potentially destroying ourselves was measured in decades. Maybe this is a universal pattern, a great filter that most civilizations fail to pass through. Nuclear war, environmental collapse, artificial intelligence run amok, or some other catastrophe might be the typical fate of species that reach our level of development. Another possibility is that advanced civilizations do exist, but they're deliberately hiding from us. Perhaps there's a kind of cosmic etiquette, a galactic policy of non-interference with younger species. They might be watching us from afar, waiting for us to reach some threshold of maturity before making contact. Or maybe they've simply moved beyond the need for the kinds of activities we would recognize as technological. A truly advanced civilization might operate on principles so foreign to our understanding that their presence would be invisible to us, like ants trying to detect the internet. Then there's the zoo hypothesis, which suggests that Earth might be a kind of nature preserve, with advanced aliens maintaining a careful boundary around our solar system to allow us to develop naturally. It's a comforting thought in some ways, the idea that we're being watched over by benevolent cosmic gardeners, but it also raises uncomfortable questions about our autonomy and the nature of our reality. Some researchers have proposed that we might be looking in the wrong places or listening for the wrong signals. Perhaps advanced civilizations have moved beyond radio communications to technologies we haven't discovered yet. Maybe they're communicating through gravitational waves, or quantum entanglement, or methods that won't be obvious to us for centuries. We could be like someone in the 19th century, trying to detect television broadcasts with a telegraph key, completely missing the signals flowing all around us. Or consider this. Maybe advanced civilizations don't expand outward in the way we expect. Instead of building vast interstellar empires, they might turn inward, creating virtual worlds of unimaginable richness and complexity. Why struggle to terraform distant planets when you can build perfect digital realms limited only by imagination. A civilization that masters virtual reality might find the physical universe suddenly irrelevant, choosing to explore infinite inner spaces rather than the finite outer cosmos. There's also the possibility that we're simply early to the party. Despite the universe's great age, most of the stars that will ever exist haven't been born yet. The universe is still young in many ways, and perhaps we're among the first intelligent species to arise. This would make us not the products of a universe teeming with ancient wisdom, but pioneers in a cosmos just beginning to wake up to itself. The silence might also be a matter of timing. Civilizations might rise and fall on timescales that make contact unlikely. Even if 1,000 intelligent species have existed in our galaxy over the past billion years, they might have been separated by such vast gulfs of time that none ever overlapped with another. We could be surrounded by the ruins of ancient civilizations, their cities long since crumbled to dust, their signals faded to whispers we lack the sensitivity to detect. Recent discoveries have only deepened the mystery. We now know that planets are common, perhaps nearly universal around stars. We've found water on Mars, organic molecules in the clouds of Venus, and subsurface oceans on the moons of Jupiter and Saturn. The ingredients for life seem to be everywhere we look, yet life itself remains stubbornly elusive. The search continues, of course. Projects like SETI, the search for extraterrestrial intelligence, scan the skies for artificial signals. Space telescopes like Kepler and TESS hunt for planets in other solar systems, looking for worlds that might harbor life. The James Webb Space Telescope is beginning to analyze the atmospheres of distant planets, searching for the chemical signatures that might indicate biological activity. Each new discovery adds another piece to the puzzle, but the overall picture remains frustratingly incomplete. Perhaps the most unsettling possibility is that the silence is not a temporary condition, but a permanent feature of our universe. Maybe intelligence is not the inevitable endpoint of evolution, but an unlikely accident. Maybe consciousness, that spark of awareness that allows us to contemplate our place in the cosmos, is so rare that it appears only once in a trillion worlds, or once in a trillion galaxies. In that case, we might be not just alone in our galaxy, but alone in our entire observable universe, a single candle of consciousness flickering in a vast and indifferent darkness. But even if we are alone, even if the universe is a place where intelligence arises only once in cosmic history, that doesn't diminish our significance. If anything, it makes us more precious, more responsible for the light we carry. We become the universe's way of knowing itself, the only eyes through which the cosmos can gaze back at its own beauty, the only minds capable of asking why the stars shine and what it all means. The Fermi paradox reminds us that for all our scientific progress, for all our telescopes and equations and theories, we still live in a universe full of profound mysteries. The silence that surrounds us might be temporary, a brief interlude before the cosmos fills with voices and signals and the busy chatter of 1,000 civilizations. Or it might be permanent, a fundamental feature of a universe where consciousness is a rare and precious accident. Either way, we continue to listen, to search, to hope. Because somewhere out there, in the vast darkness between the stars, there might be others like us, looking up at their own night sky and wondering if they too are alone. As we journey deeper into the cosmic darkness, searching for the birthplaces of stars, we encounter something extraordinary nestled within these stellar nurseries. The same gravitational forces that coax hydrogen clouds into glowing suns don't stop there. they continue their patient work, gathering dust and gas into swirling disks around newborn stars, and from these disks, something remarkable emerges. Planetary systems, picture this. A young star has just ignited at the heart of its collapsing cloud, but surrounding it, like a cosmic potter's wheel, spins a flat disk of leftover material. This protoplanetary disk, as astronomers call it, is where worlds are born. It's a scene playing out countless times across the galaxy, in every stellar nursery we've explored. The process begins simply enough. Within the disk, tiny grains of dust no bigger than smoke particles start to stick together when they collide. It's delicate work, this cosmic construction. These dust bunnies grow slowly, patiently, grain by grain, until they become pebbles, then rocks, then boulders. Gravity, ever the helpful assistant, begins to take notice of these growing clumps and starts pulling more material toward them. Over millions of years, some of these rocky cores grow large enough to capture the lighter elements, hydrogen and helium, from the surrounding disk. These become the gas giants, the Jupiters and Saturns of their systems, massive worlds wrapped in thick atmospheres. Others remain rocky and terrestrial, like our own Earth, Mars, and Venus, solid worlds where the drama of geology and perhaps even biology might one day unfold. But here's where the story becomes deeply personal, profoundly moving. Among all these forming worlds, some find themselves in what astronomers call the habitable zone, that gentle region around a star where temperatures are just right for liquid water to exist. Not too hot that water boils away into space, not too cold that it freezes solid. It's a cosmic Goldilocks zone, and it's where the possibility of life as we know it can take hold. Earth, of course, is our example of such a world. 4.5 billion years ago, our planet formed from the same stellar nursery processes we've been exploring. The heavy elements forged in the hearts of ancient stars, the carbon and oxygen and iron scattered by their dying breaths, all came together in this spinning disk around our young sun. We are literally made of star stuff, assembled in a cosmic cradle, nurtured by the same forces that birth suns. And this raises one of the most profound questions we can ask. Are we alone? In a universe filled with hundreds of billions of galaxies, each containing hundreds of billions of stars, many of which likely have their own planetary systems, surely life must have emerged elsewhere. The numbers seem to demand it. The ingredients for life: carbon, hydrogen, oxygen, nitrogen, are among the most common elements in the universe, forged in stellar cores and scattered by stellar deaths across the cosmos. Yet when we look out into the universe, when we listen with our radio telescopes and scan the skies with our most sensitive instruments, we find something puzzling: silence. If the universe should be teeming with life, if intelligence should have emerged countless times across cosmic history, why haven't we encountered it? Perhaps life is far rarer than we imagine. Perhaps the chain of events that led from simple chemistry to complex biology on Earth required such an unlikely sequence of circumstances that it's happened only once, or only a handful of times, in our entire galaxy. Maybe the emergence of multicellular life, or intelligence, or technological civilization requires such precise conditions that we are, in fact, alone or nearly so. Or perhaps life is common, but technological civilizations are fragile, short-lived things. Maybe they develop the ability to destroy themselves faster than they develop the wisdom to refrain from doing so. Maybe the silence we hear is not the silence of an empty universe, but the silence of a universe filled with worlds where intelligence flickered briefly and then went dark. There's another possibility. one that's both humbling and oddly comforting. Perhaps advanced civilizations are out there, but they're so far beyond us in their development that they have no more interest in communicating with us than we have in trying to have philosophical discussions with the bacteria in our garden soil. They may see us as we see the microbes. Interesting, perhaps, but not worth the effort of meaningful contact. Or maybe, just maybe, they're trying to protect us. Perhaps there's something like a cosmic protocol, a galactic agreement to let young civilizations develop on their own, without interference from their elder siblings among the stars. We might be living in a kind of nature preserve, observed but not contacted, studied but not disturbed. The silence could also be a matter of time and distance. The universe is vast, unimaginably so, and even signals traveling at the speed of light take millennia to cross from one star system to another. A civilization might send us a message, but by the time it reaches us, they might be long gone. We might send a reply, but by the time it reaches them, we might be gone too. Conversations across the cosmos require patience measured not in years, but in geological ages. Some scientists suggest that we're looking in the wrong places or listening for the wrong things. Maybe advanced civilizations don't use radio waves to communicate. Maybe they've moved beyond electromagnetic radiation entirely, using some form of communication we haven't even discovered yet. We might be like someone trying to join a conversation by tapping out Morse code while everyone else is using smartphones. But here's what's beautiful about our search, our wondering, our cosmic loneliness. It drives us to keep looking, keep exploring, keep pushing the boundaries of what we know. Every new exoplanet we discover, every potentially habitable world we identify, brings us closer to answering that fundamental question. The James Webb Space Telescope is already analyzing the atmospheres of distant worlds, looking for the chemical signatures that might indicate life. And in the meantime, while we search and wonder and listen to the cosmic quiet, we continue to be part of the story. The stellar nurseries are still active, still birthing new suns, still spinning out new worlds. The cycle that created us continues, will continue long after we're gone. Somewhere out there, in a molecular cloud we'll never see, a new star is igniting. Around it, a disk of dust and gas is slowly, patiently assembling itself into worlds. Perhaps on one of those worlds, billions of years from now, someone will look up at their night sky and wonder the same things we wonder. They'll see the light of stars born in nurseries like the ones we've explored, carrying elements forged in stellar hearts, telling the same ancient story of cosmic birth and growth and change that we're part of tonight. The universe continues its quiet work of creation, continues to spin new stories from stardust and gravity and time. Whether we're alone in our wondering or part of a vast community of questioners scattered across the galaxies, we remain children of the stars, products of cosmic nurseries, witnesses to the ongoing miracle of stellar birth. And that, perhaps, is enough. And so here we are, gentle listeners, gathered in the quiet corners of the universe where starlight meets wonder, where curiosity wraps itself in the soft blanket of evening. We've traveled together through cosmic time, from the first whispered moments after the Big Bang to the grand spiral cities of stars that populate our night sky. We've watched darkness give way to light, seen matter organize itself into the most beautiful structures the cosmos has ever known, and discovered that we ourselves are part of this ancient, ongoing story. Think of it, if you will, as the universe learning to tell stories about itself. For billions of years, gravity has been the patient editor, dark matter the invisible framework, and stars the brilliant punctuation marks scattered across the manuscript of space. Galaxies formed like chapters in a book that writes itself, each one unique, each one carrying the memory of cosmic birth and the promise of futures we can barely imagine. We've seen how the Milky Way, our own galactic home, emerged from this grand narrative, a spiral of stars and stories spinning quietly through the void. We've watched as smaller galaxies were absorbed, their stars becoming part of our extended family, their histories folded into our own. And we've glimpsed ahead to that distant future when Andromeda, our nearest large neighbor, will dance with us in a slow-motion waltz that will reshape both our destinies. But perhaps the most remarkable part of this story is that we are here to witness it at all. Every atom in your body, every breath you take, every thought drifting through your mind as you listen to these words, was forged in the nuclear furnaces of ancient stars. You are made of galaxy stuff, quite literally. The calcium in your bones, the iron in your blood, the oxygen you breathe. All of it was scattered into space by stars that lived and died long before our sun was even a glimmer in a cosmic cloud. This connection runs deeper than mere chemistry. We are not separate from the universe, looking in from the outside. We are the universe becoming aware of itself, cosmic matter organized in such a way that it can contemplate its own existence. When you gaze up at the stars, you are looking at your own deep ancestry. When you wonder about distant galaxies, you are participating in the universe's ancient conversation with itself. And what a conversation it is. From those first primitive proto-galaxies, chaotic and irregular, to the elegant spirals and majestic ellipticals we see today, the cosmos has been constantly evolving, constantly creating new forms of beauty. Gas clouds collapse into stars. Stars live their brief or lengthy lives, then scatter their enriched contents back into space, providing the raw materials for the next generation. It's a cycle of death and rebirth that has been ongoing for over 13 billion years, and it continues even now. The universe is still young, still growing, still surprising us. With each new telescope, each deeper observation, we discover that our cosmic neighborhood is more complex, more beautiful, and more interconnected than we ever imagined. Galaxies don't exist in isolation. They form communities, clusters, vast networks connected by invisible filaments of dark matter. They influence each other across millions of light years, their gravitational fields reaching out like gentle hands across the void. We've learned that time itself becomes our ally in this exploration. When we look out into space, we look back through time, seeing galaxies as they were millions, billions of years ago. That light has traveled across unimaginable distances just to reach us, carrying messages from epochs when the universe was young, when the first stars were lighting up the cosmic dark ages, when galaxies were just learning how to be galaxies. The James Webb Space Telescope and its predecessors have given us glimpses of this ancient light, showing us baby galaxies in their cosmic cribs, irregular and energetic, full of the chaos and creativity that marks all new beginnings. These observations remind us that everything we see today, every elegant spiral arm and glowing galactic core, began as something much simpler, much smaller, much more uncertain. And yet, for all our scientific understanding, for all our telescopes and equations and computer simulations, galaxies retain an essential mystery. They are more than the sum of their parts, more than just collections of stars and gas and dark matter. They are emergent phenomena, complex systems that exhibit behaviors and beauty that cannot be predicted from their individual components alone. This is perhaps why they speak to us so deeply. In a galaxy, we see the same principles that govern all complex systems, from the cells in our bodies to the communities we build, to the thoughts in our minds. Structure emerges from chaos. Beauty arises from simple rules applied over vast scales of time and space, and the whole becomes greater than its parts. As we drift toward the end of our cosmic journey tonight, consider this. Somewhere out there, in a galaxy whose light has not yet had time to reach us, new stars are being born. Stellar nurseries are collapsing under their own gravity, igniting nuclear fires that will burn for millions or billions of years. Planets may be forming in the disks around these young stars, and perhaps, on some of those worlds, the first stirrings of life are beginning. The story we've told tonight is not just history, it's prophecy. The same processes that created our galaxy, our sun, our world, are still at work throughout the universe. New chapters are being written in the cosmic story every moment. New characters are entering the stage. New possibilities are being born from the endless creativity of matter and energy dancing together in the void. And what of our own chapter in this vast story? We find ourselves at a remarkable moment in cosmic history. We are perhaps the first generation of humans to truly understand our place in the galactic community, to see ourselves as citizens of the Milky Way, rather than merely inhabitants of Earth. We've learned to read the ancient light of distant stars, to decode the messages written in gravitational waves, to trace our ancestry back through generations of stellar nucleosynthesis to the very beginning of time. This knowledge brings with it both humility and wonder. Humility because we see how small we are in the vast scheme of things, how brief our individual lives are, compared to the billion-year life cycles of galaxies. But also wonder, because we realize that we are part of something magnificent, something that has been unfolding for cosmic ages and will continue long after we are gone. We are the universe awakening to itself, matter organized in such a way that it can contemplate matter, atoms arranged so that they can ponder atoms, stardust that has learned to wonder about stars. In a very real sense, when we study galaxies, we are studying ourselves. When we marvel at the beauty of spiral arms or the mystery of dark matter, we are participating in the universe's ongoing project of self-discovery. The galaxies will continue their ancient dance long after our sun has faded to a white dwarf, long after Earth has become a cold, airless rock orbiting a dying star. New stars will be born, new worlds will form, and perhaps new forms of life will emerge to carry on the conversation between matter and mind, between the cosmos and consciousness. But that is all in the unimaginably distant future. For now, for this brief moment in cosmic time, we are here. We are the universe's way of knowing itself, and what a privilege that is. Every time you look up at the night sky, every time you feel that sense of wonder at the vastness and beauty of space, you are fulfilling one of the universe's deepest purposes. You are the cosmos contemplating itself with curiosity and love. The stars that shine down on you tonight are the same stars that have witnessed the entire history of our galaxy. They have seen the birth and death of countless generations of stars, the slow evolution of the Milky Way from a small, irregular collection of gas and dust to the magnificent spiral we call home today. They will continue to shine long after we are gone, carrying forward the story that we have been privileged to glimpse and share. So as you prepare for sleep tonight, as your thoughts begin to soften and your breathing slows, remember that you are not separate from this cosmic story. You are part of it, woven into its very fabric. The atoms in your body have traveled across billions of years and trillions of miles to be here, now, in this moment. allowing you to contemplate the very galaxies that gave them birth. Rest well, fellow traveler in the cosmic dark. Dream of spiral arms and stellar nurseries, of dark matter and distant quasars, of the slow, patient work of gravity writing poetry in light across the sky. And know that tomorrow, when you wake, you will still be part of this magnificent story, still a conscious fragment of the universe exploring itself, still a temporary arrangement of stardust gifted with the ability to wonder. The galaxies keep their vigil in the night sky, spinning slowly through space and time, carrying forward the ancient story of cosmic birth and evolution. And you, dear listener, are part of that story. A brief but brilliant chapter in the ongoing epic of matter learning to dream. We've ventured far through the cosmic theater of creation, from the first whispers of matter after the Big Bang to the majestic spiral arms of galaxies spinning through space. We've witnessed the universe light its first stars, watched galaxies collide in slow-motion ballets, and traced the invisible threads that bind everything together. But our journey isn't quite complete. There's one more chapter to write in this cosmic story, one that brings everything full circle. You see, the universe isn't just about vast structures and ancient light. It's about connection. It's about the profound realization that every atom in your body, every breath you take, every thought drifting through your mind as you listen to these words was forged in the nuclear furnaces of stars that lived and died billions of years ago. You are not separate from the cosmos. You are the cosmos becoming aware of itself. Think about that for a moment. The iron in your blood was created in the core of a dying star. The calcium in your bones was scattered across space by a supernova explosion. The oxygen you breathe was gifted to the universe by countless generations of stars. You are literally made of stardust, and so is everyone you've ever loved, every tree you've ever sat beneath, every ocean you've ever gazed across. This isn't poetry, though it sounds like it. This is physics. This is the deep, beautiful truth that connects you to the most distant galaxy, to the earliest moments after the Big Bang, to the very fabric of space and time itself. When you look up at the night sky, you're not looking at something foreign and distant. You're looking at your cosmic family tree, the stellar nurseries where your very essence was born. And here's what makes it even more remarkable. The universe has been preparing for you. Not you specifically, perhaps, but for consciousness itself. For billions of years, stars have been cooking up the heavy elements necessary for complex chemistry. Galaxies have been forming and evolving, creating the stable environments where planets can form and life can flourish. The cosmic web has been weaving itself into the perfect architecture for matter to organize, for complexity to emerge, for minds to arise that can contemplate their own existence. You are the universe's way of knowing itself. Through your eyes, the cosmos sees its own beauty. Through your mind, it ponders its own mysteries. Through your wonder, it experiences awe at its own magnificence. This isn't metaphor. This is the most literal truth we know. Conscious beings like us are how the universe becomes self-aware. And what does this mean for our place in the grand scheme of things? It means we're not cosmic accidents or insignificant specks. We're the universe's greatest achievement so far. We're matter that has organized itself so exquisitely that it can contemplate matter. We're stardust that has learned to wonder about stars. We're the cosmos dreaming about itself. This perspective changes everything. When you're feeling small or lost or overwhelmed by the vastness of existence, remember that you carry within you the entire history of the universe. Every heartbeat echoes with the rhythm of cosmic time. Every thought you think participates in the universe's ongoing conversation with itself. Every act of kindness, every moment of love, every flash of creativity adds to the sum total of consciousness in the cosmos. And here's the beautiful paradox. The more we learn about the universe, the more we realize how much we don't know. Every answer reveals new questions. Every discovery opens new mysteries. The cosmic microwave background whispers secrets we're still learning to decode. Dark matter and dark energy remain tantalizingly invisible. The deepest questions about time, consciousness, and reality itself continue to dance just beyond our understanding. But perhaps that's exactly as it should be. Perhaps mystery is not a problem to be solved, but a gift to be savored. Perhaps wonder is not a temporary state to be outgrown, but a fundamental feature of what it means to be conscious in a universe that never stops surprising us. So as we drift toward the end of our cosmic journey together, as your thoughts begin to soften and your breathing slows, remember this: you are both infinitely small and infinitely significant. Small in the sense that you are one brief flicker in the vast sweep of cosmic time. Significant in the sense that you are how the universe experiences beauty, meaning, and wonder. Tomorrow, when you wake up, you'll step outside and feel the warmth of our neighborhood star on your face. You'll breathe air that connects you to every living thing on Earth. You'll look up at a sky scattered with distant suns, each one a possible hearth for worlds we can barely imagine. And if you remember this journey we've taken together, you might smile at the knowledge that you're not just observing the universe. You are the universe, briefly conscious of its own infinite mystery. The cosmic story continues, and you are both its author and its audience, its question and its answer, its dreamer and its dream. Rest well, fellow Stardust. This place, this universe we find ourselves in, is not merely a collection of distant lights scattered across darkness. It is a vast, interconnected web of creation where every atom in your body once lived inside the burning heart of a dying star. Tonight, as you settle into rest, let me tell you about the cosmic cradles where stars are born, for their story is ultimately your story, written in fire and starlight across billions of years. Picture, if you will, the deepest regions of space, far from any sun, where temperatures hover just a few degrees above absolute zero. Here, in the vast darkness between stars, float enormous clouds of gas and dust so tenuous they make the best vacuum we can create on Earth seem dense by comparison. These are the stellar nurseries, the molecular clouds where the next generation of stars quietly gestates, sometimes for millions of years, before their first light pierces the cosmic dark. These nurseries are not empty voids, but rather delicate, ethereal structures, gossamer threads of hydrogen and helium, mixed with the precious dust of elements forged in ancient stellar furnaces. Carbon, oxygen, silicon, iron, all the building blocks of worlds and life itself drift here in microscopic grains, each no larger than the particles in cigarette smoke, yet collectively forming clouds that can span hundreds of light years across. Within these vast stellar wombs, gravity works with infinite patience. It whispers to particles of gas and dust, drawing them together grain by grain, molecule by molecule. The process is so gradual that if you could watch it unfold, it would seem like a cosmic meditation, a slow-motion dance of matter responding to the gentle tug of gravitational attraction. But gravity, for all its subtlety, is relentless. Over tens of thousands of years, tiny irregularities in these clouds begin to grow. A region slightly denser than its surroundings pulls in more material, becoming denser still, which allows it to pull in even more matter. It's a feedback loop written in the language of physics, where success breeds success and mass attracts mass. As these dense pockets continue to grow, something remarkable begins to happen. The cloud starts to fragment, breaking apart into smaller, denser clumps. Each clump becomes a potential star, a knot of matter slowly contracting under its own weight. The process accelerates now, though still unfolding over geological timescales that dwarf human experience. Within each contracting clump, the temperature begins to rise. As gravity pulls the material inward, the particles move faster, colliding more frequently, generating heat through the simple physics of compression. What began as a cloud colder than the Antarctic winter slowly warms, degree by degree, century by century. The transformation is gradual but inexorable. The clump becomes more spherical as gravity works to pull all the material toward the center. A primitive atmosphere of gas and dust begins to form around the growing core. This is no longer just a cloud, but a protostar, a star in the making, still hidden within its birth cocoon of dust and gas. For perhaps 1,000,000 years, the protostar continues to contract and heat up. Its surface temperature rises from the frigid cold of space to hundreds, then thousands of degrees. It begins to glow, first with invisible infrared light, then with a dull red radiance that can barely penetrate the shroud of dust surrounding it. The surrounding disk of material doesn't simply fall straight into the growing star. Conservation of angular momentum, the same principle that makes a figure skater spin faster when she pulls in her arms, causes the infalling matter to form a swirling disk around the protostar. This disk becomes a stellar nursery within a nursery, the birthplace not just of the star itself, but potentially of an entire planetary system. Within this disk, dust grains begin to stick together, forming larger and larger aggregates. Tiny pebbles become rocks, rocks become boulders, boulders become asteroids, and asteroids may eventually become the building blocks of planets. While the star gestates at the center of this cosmic whirlpool, the raw materials for worlds slowly accrete in the cooler outer regions. But let us return to the star itself, for its birth is approaching. Deep within the contracting core, temperatures climb toward unimaginable heights. 10,000 degrees, 100,000, 1,000,000 degrees. The hydrogen nuclei, normally kept apart by their mutual electrical repulsion, begin to move so fast that they can overcome this barrier when they collide. And then, in a moment that represents the culmination of millions of years of gravitational collapse, nuclear fusion ignites. Hydrogen nuclei slam together with such force that they fuse, forming helium and releasing tremendous amounts of energy in the process. The star is born. The energy released by fusion creates an outward pressure that finally balances the inward pull of gravity. The long collapse ends, and the star settles into what astronomers call the main sequence, a stable phase of nuclear burning that can last billions of years. Our sun has been in this phase for about 5 billion years and has another 5 billion to go. The newborn star's first light begins to push away the remaining dust and gas of its birth cloud. Stellar winds, streams of charged particles flowing from the star's surface, help clear away the debris. Slowly, the star emerges from its cocoon, revealing itself to the cosmos for the first time. But stellar birth is rarely a solitary affair. Most stars are born in clusters, sometimes containing hundreds or thousands of siblings, all emerging from the same giant molecular cloud. These stellar nurseries can produce stars of vastly different masses, from tiny red dwarfs that will burn for trillions of years, to massive blue giants that will exhaust their fuel in just a few million years. The most massive stars, dozens of times heavier than our sun, burn through their nuclear fuel with spectacular intensity. They shine thousands of times brighter than the sun, but their profligate energy consumption means they live fast and die young. When they exhaust their fuel, they explode as supernovae, blasting their outer layers into space and enriching the interstellar medium with heavy elements forged in their cores. These stellar explosions serve a crucial purpose in the cosmic cycle of creation. The shock waves they create can trigger the collapse of nearby molecular clouds, sparking new rounds of star formation. Meanwhile, the heavy elements they scatter, elements like carbon, oxygen, and iron, become incorporated into the next generation of stars and planets. This is how the universe gradually becomes more complex and chemically rich over time. The first stars, born from the pure hydrogen and helium created in the Big Bang, lived and died to create the heavier elements. Those elements became part of new molecular clouds, which gave birth to new stars and the first rocky planets. Some of those planets developed oceans and atmospheres, and eventually, life itself. You are part of this story. Every atom of oxygen you breathe was forged in the core of a dying star. The calcium in your bones, the iron in your blood, the carbon that forms the backbone of your DNA. All of it was created in stellar furnaces and scattered into space by ancient supernovae. You are not separate from the cosmos. You are a temporary arrangement of cosmic material, stardust contemplating its own origins. The stellar nurseries continue their work even now. In the constellation Orion, visible on winter nights, lies one of the most active star-forming regions in our vicinity. The Orion Nebula, that fuzzy patch of light in the sword of the hunter, is actually a stellar nursery where new stars are being born at this very moment. Through telescopes, we can see the glowing gas illuminated by hot young stars and the dark lanes of dust where the next generation of stars is still gestating. In other parts of our galaxy, radio telescopes detect the telltale signatures of molecules in dense molecular clouds, mapping out the cold, dark regions where gravity is slowly gathering material for future stellar births. These observations reveal a galaxy that is very much alive, constantly recycling its material through the cycle of stellar birth, life, and death. The process continues on scales both vast and intimate. In the Eagle Nebula, towering pillars of gas and dust stretch across light years, their tips sculpted by the radiation from nearby massive stars. Within these pillars, dense knots of material are collapsing to form new stars, even as the pillars themselves are slowly being eroded away by stellar winds. Sometimes, the birth of stars is anything but gentle. In regions where multiple massive stars form close together, their combined radiation and stellar winds can create enormous bubbles in the interstellar medium, structures hundreds of light years across. The shells of these bubbles, compressed by the pressure from within, can become sites of new star formation, creating a chain reaction that propagates across the galaxy. Other times, stellar birth is triggered by more dramatic events. When galaxies collide, the gravitational tides can compress gas clouds and trigger massive bursts of star formation. The beautiful spiral arms of galaxies like our own Milky Way are actually density waves that sweep through the galactic disk, compressing gas clouds and lighting up chains of stellar nurseries that trace out the spiral pattern. Even the supermassive black holes at the centers of galaxies play a role in regulating star formation. When they actively feed on surrounding material, they can generate powerful jets and winds that either trigger or suppress star formation in their host galaxies. The relationship between these cosmic monsters and the delicate process of stellar birth is one of the most active areas of research in modern astronomy. As we probe deeper into space with ever more sophisticated telescopes, we're discovering that stellar nurseries come in many varieties. Some are dense, compact regions where stars form rapidly and in great numbers. Others are more diffuse, taking their time to slowly condense new stars over many millions of years. The environment matters, affecting not just how quickly stars form, but also their ultimate masses and the likelihood that they'll be accompanied by planetary systems. The James Webb Space Telescope, with its unprecedented ability to peer through dust clouds using infrared light, is revolutionizing our understanding of these stellar birthplaces. It can see the warm glow of dust heated by embedded protostars, revealing the hidden stages of stellar formation that were invisible to previous generations of telescopes. What we're learning is that star formation is a remarkably complex process, influenced by factors ranging from the large-scale structure of galaxies down to the microscopic physics of dust grains. Magnetic fields thread through molecular clouds, affecting how gas can flow and collapse. Turbulence creates eddies and vortices in the cosmic gas, sometimes helping and sometimes hindering the formation of new stars. The chemistry of these stellar nurseries is surprisingly rich. Even in the cold depths of space, molecules form and break apart, creating a complex web of chemical reactions. Water, methanol, formaldehyde, and even more complex organic molecules have all been detected in molecular clouds. This chemistry affects how efficiently gas can cool and collapse, and it may also provide some of the raw materials for life on planets that form around the newly born stars. When we consider the formation of our own solar system 4.5 billion years ago, we're looking at just one example of this cosmic process. Our sun condensed from a molecular cloud that had already been enriched by multiple generations of stellar death and rebirth. The planets formed from the leftover material in the protoplanetary disk, with the rocky inner planets like Earth incorporating the heavy elements created by long-dead stars, the water in Earth's oceans, the oxygen in our atmosphere, the complex organic molecules that eventually gave rise to life. All of these can trace their origins back to those stellar nurseries where chemistry and physics conspired to create the raw materials for worlds and biology. But stellar birth is not just about the past, it's about the future as well. New stars forming today will burn for millions or billions of years, potentially providing the energy needed to sustain life on any planets that form around them. Some of the stars being born right now in molecular clouds throughout the galaxy may one day host civilizations that look up at their night sky and wonder about their own cosmic origins. The cycle continues and will continue for trillions of years to come, though it will not go on forever. As the universe ages and expands, the raw materials for star formation become more dispersed. The rate of stellar birth has already declined significantly from its peak billions of years ago. Eventually, the last molecular clouds will collapse to form the final generation of stars, and then stellar nurseries will become extinct, leaving behind only the slowly cooling embers of a universe that once blazed with the light of constant creation. But that end lies in the unimaginably distant future. For now, the cosmic cradles continue their patient work, gathering the scattered ashes of dead stars and breathing new life into them. In the cold depths of space, gravity performs its ancient alchemy, transforming diffuse gas into blazing suns that will light up the cosmos for eons to come. Each new star that forms carries within it the potential for worlds, for complexity, for the emergence of consciousness itself. When you look up at the night sky, you're seeing not just points of light, but the products of countless stellar nurseries, each one a testament to the universe's endless creativity and its drive toward ever greater complexity and beauty. The story of stellar birth is ultimately a story about transformation, about how the universe takes simple raw materials and, through the patient application of physical laws, creates structures of breathtaking complexity and beauty. From cold molecular clouds to blazing stars to rocky planets to living beings capable of contemplating their own existence, it's all part of one continuous narrative of cosmic evolution. And you, lying there in the quiet of the evening, are both a product of this process and a witness to it. The very neurons firing in your brain as you listen to these words are made of elements forged in stellar cores. The oxygen you breathe, the carbon in your cells, the iron in your blood, all of it was created in the heart of a star and scattered into space by stellar death, only to be gathered up again in the molecular cloud that gave birth to our solar system. In this sense, stellar nurseries are not just the birthplaces of stars. They are the birthplaces of everything complex and beautiful in the universe. They are the cosmic wombs where matter learns to organize itself into ever more intricate and wonderful forms. From the first simple atoms emerging from stellar cores, to the complex molecules floating in interstellar space to the delicate structures of living cells. It's all connected by an unbroken chain of transformation that stretches back to those first stellar nurseries in the early universe. The process is ongoing, eternal, cyclical. Stars are born, live their lives, and die, enriching the cosmos with the products of their nuclear alchemy. New molecular clouds form from this enriched material, ready to give birth to new generations of stars with their own potential for planetary systems and perhaps life itself. It's a cosmic recycling program of unimaginable scale and beauty, driven by the fundamental forces of nature and the arrow of time. As you drift towards sleep, consider this. Somewhere in the galaxy right now, in a cold molecular cloud light years across, gravity is gathering material for a star that won't be born for another 1,000,000 years. That star may shine for billions of years, perhaps warming planets where life will evolve and flourish. Beings on those worlds may one day look up at their night sky and feel the same sense of wonder and connection that you feel now, knowing that they too are made of star stuff, temporary patterns in the cosmic dance of matter and energy. The stellar nurseries remind us that we are not isolated beings on a lonely planet, but integral parts of a living, evolving cosmos. We are the universe becoming aware of itself, stardust contemplating the very processes that created us. In the gentle collapse of molecular clouds and the nuclear fire of newborn stars, we see not just the mechanics of stellar formation, but the deeper story of cosmic evolution, of complexity emerging from simplicity, of consciousness arising from matter. And in that recognition, perhaps we find a deeper sense of belonging, a profound connection to the cosmos that created us and of which we remain an inseparable part. The stellar nurseries are still at work, still weaving new stars from the ancient materials of space, still participating in the grand project of cosmic evolution that began with the Big Bang and continues to this day. In the end, the cosmic cradles where stars are born are also the cradles of everything we are and everything we might become. They represent the universe's endless capacity for renewal, for transformation, for the creation of beauty and complexity from the simplest of raw materials. They are the workshops where gravity and physics collaborate to build the future, one star at a time, in a process so fundamental and beautiful that it connects every atom in your body to the vast dance of cosmic creation that surrounds us all. So rest now, knowing that you are held by the same forces that light the stars, composed of the same materials that fill the cosmic nurseries, part of the same ongoing story of transformation and creation that has been unfolding for nearly 14 billion years and will continue long after our brief moment in cosmic time has passed. You are not just in the universe, you are the universe, experiencing itself through your consciousness, dreaming itself through your dreams, and finding meaning through your capacity for wonder at the cosmic cradles where stars are born.